Oneness Evolving here. Lovely to see you out in my garden. I shouldn't really be out here because it's mizzling, but I mean, listen to the birds. And I'll show you what's going on out here because it's just lovely. Where the hell's the Tootie Roundy thing? There we go. Right, Tootie Roundy accomplished. Actually, look at the lawn. There are a lot of buttercups. And yes, I'm going to get to what I've been doing for God and me, but this is too lovely to miss. Look at all the raindrops. And hear the birds. It's just beautiful out here. And this is the corner where I'm really enjoying the colours at the moment. And you got to see the flowers. All covered in raindrops. And the smell. This shrub, its flowers just smell beautiful. And look at the maple. Getting close, see the raindrops on the leaves. It's just lovely here. And that's a view you don't usually see, but there it is. So, just standing in the garden showing you the colours. Before we go inside and I tell you what I've been writing about today. Oh look, there's a weed that's flowering. Even the weeds are beautiful, but really I need to pull it out, otherwise I'll have too many of them. Some little roses here. Mostly what you can see is the lilies coming up. There's a buttercup in there that I haven't pulled out. And look, I haven't been able to show you this before, the Spanish iris. I'm really fond of this. It's just the most elegant flower. It's beautiful. And out here with the rain and the peace and quiet. Look at my neighbour's tree fern. Nothing's moving. And there's the garden. And see the lilies just coming up like a firework. Yesterday was officially Guy Fawkes, but it was raining, so it'll probably all happen in the weekend. I'm really pleased with how this is all looking. And I'm going to show you what's happening here, because I haven't for a little while. Look at the feverfew, it's so bright. And then we have the sedum here, which is just this fabulous colour. And everything is saturated and rich because of the rain. And look at this calendula flower. It's so perfect. And then look at the green of the buds and how everything is arranged so beautifully. The other thing I want you to see is look at these massive lilies. They're enormous. These are Lilium regale. And they're big. They're big. They just shoot up like rockets. And they're multiplying. They're happy in here. See, there's a little baby one at the back. So I'm really pleased about that. And then there's these ones. I don't even know what they are. There's some mad species lily that came up because I had some other one and it reverted. And then you've still got the sedum here. And look, I've discovered I did not deadhead that freesia, and I need to because I just don't need any more freesias in there. See, the freesias are here, they're all dying down, and I deadhead them because there's lots of them. So, turn the camera around, let me go inside, take my hat off, and tell you what I've been doing today. It's just so beautiful out here, it's quiet. So, take the keys out of the front door. Shut the front door. Keys in their place. Put my hat in its place. Everything has a place. It's just easier if it's there the next time I want it. And here we go into the lounge. Peace and quiet. So, just get myself organised here. It's been a really peaceful morning here, and I'm aware that the US election is unfolding today, so I won't be surprised if it's a very quiet live and people catch it on the replay, because everybody is just, agog with what's going on overseas, and that's fine. But I'm just going to keep going, because my little journey continues too, my little creation. So today, a little notepad that tells me what I did. I wrote, this is what I wrote about. So, and you're thinking, what do little spinning pieces of energy have to do with manifestation? Really? Why do I keep blithering on about manifestation and then talking about atoms and protons and electrons and Planck spherical units, whatever the heck they are, named by the guy Max Planck, who was kind of the father of quantum physics? What is the deal? Well, in my writing, I went back over a lot of that. It's like I've done a chunk all about this, and there was just something that didn't feel quite right about it, and so I actually pretty much went back to the beginning of the document that I've been doing and just read it through, and I eventually realised that there were a couple of places where I was using one word, but it was meaning two things. And this is something that has really given me grief when I'm learning from other people and they do that. And in this case, the word was particle, right? Because a particle can be an atom, it can be a grain of sand, it can be, one little piece of a vapor. It's a particle, it's a tiny small thing. But I was reading things and thinking, I don't know what particle I'm talking about here. And we can be sure that if I don't know what particle I'm talking about, nobody else is going to know either. So I actually had to sit there and untangle that, and I did that because I want this to be clear. This is the thing that I do well, is explain things explicitly. I think sometimes I wrap too many words around them, but my goal is to be so clear that you can't be confused about what I'm saying. So I put effort into that. Excuse me. So then I actually did a little piece of new writing, and by new writing I mean I had a few ideas about a point that I wanted to make, but I actually wrote it. I actually explained it and broke it out and told a story. And the little piece that I was talking about, if you heard my my lives for the last couple of weeks or 3 weeks, I've been talking about electrostatic energy, which sounds terribly boring, until you realise that this is actually what holds the universe together. Seriously, electrostatic energy, that same stuff that you get, if you rub a balloon and then you can lift your hair up with it, or if you're wearing something nylon, and you take it off and it's staticky and it goes as you take your clothing off, or if it's dark and you look, actually see little flashes of light. That stuff is the same stuff that holds the universe, all the matter in the universe together. Really. Which is a little bit more interesting than just static electricity. But the problem was that I've been talking about these weird little things called Planck spherical units, which are just tiny spinning vortexes of energy, right? And they're very, very small, and there's an awful lot of them. And my understanding of a Planck spherical unit is that it is a spinning vortex of electrostatic energy. And I did not know what electrostatic energy actually was. I'm used to the fact that it does that annoying thing when I take off my clothes at night if it's static, if it's something, plasticky and it's close to my skin. I know, we all know what the effect of static electricity is. We've all seen lightning. That's static electricity discharging too. But what actually is it? That I could not say. And if I'm going to be explicit and explain these ideas so that anybody can start at the beginning and go through to the end and learn and understand as they go, well, if I don't know what it is, you sure as hell don't. So I had to look it up. So I had to break down what is electrostatic energy, and it's about potential energy. It's energy that's stored in the electric field that is between charged particles. And so I had to go, well, what is potential energy? Well, that's like if you have a bow and an arrow and you pull the arrow back, there's potential energy all over the place. It's not released until you let that arrow go. It's energy that's waiting to do something. Another more familiar example, perhaps, is if you just have a ball and you put it at the top of a slope. It's sitting there, not doing anything. But if you let it go, all that energy, the potential energy, is expressed in the ball rolling down the slope, and it might bounce, and it might make noise, and it might hit something in the bottom and move it. All of that is the potential energy being expressed. But at the top of the slope, it's unexpressed. It's just sitting there, waiting to happen. That's potential energy. And you have a system, right? You have a system of something that's interacting together. It's held in a system of charged particles. That's what electrostatic charge is. It's the charge of a system. It's the potential energy of a system of charged particles. So a system is a system is anything that works together with something else, really. It's, you got a bunch of things, and you have a computer system, or you have a circulatory system, or you have a house and cooling system, or whatever it is. It's a system. It's just, a bunch of things that work together to achieve a certain end. And then, charged particles, we talked about those too. The structure of an atom is that it has a positively charged nucleus, and that it has negatively charged electrons whirling around outside it, and they exist within a certain area of space around the nucleus. And, it's not a billiard ball, it's just an area of space with these tiny electrons whizzing around in this tiny positively charged nucleus. And it's electrostatic charge that actually holds those electrons around the nucleus. Otherwise, they'd fly off and go and do something else. But that charge holds them in place. So that's electrostatic charge. And then the last thing I had to explain was that it's the electric field that sits in between the charged particles. And I thought, what the hell is actually an electric field? And when I looked it up, because I had to look it up, it's like, okay. The best way I could talk about it was, or to start talking about it, was to talk about what happens when you have a big, like let's say a big, 1 meter wide or bigger vessel of water. It's round, it's probably helpful, doesn't have to be. And it's got a small plug in the middle, and it's full of water. And, the water is draining down the plug, right? But if you take a leaf and you put it on the outside of that vessel of water, the leaf is just going to sit there. The water's spinning and going down the middle here, but out there, the leaf is just going to sit there. The water doesn't appear to move at all. And if you choose a spot in between the centre and the edge of that vessel, you put the leaf about here, well, it's going to move, but it's going to be slow. And right in here by the centre, it's going to go round and round and faster and faster and go down the hole. And that's what an electric field is like. It's strong in the middle, it's weak at the outside. And then there comes a point when it stops, and that's actually got a name. It's the charge radius of the atom. The radius is from the centre to the outside, and it is how far away can you get from the nucleus before the charge that is associated with this group of charged particles that we call an atom, before it stops. That's the charge radius of a particle. So, anyway, that's the context, and I've been wanting to link that with these tiny little things that are spinning. Then I say they're called Planck spherical units. Well, actually, it's Nassim Haramein who said that. And they make up all the matter in the universe, and they do. But how do I make the connection between electrostatic energy, which is what those things are made up of, and what I've just told you? So I'm wanting to make the connection. And the problem with thinking about an electric field as something that is like a basin of water when it's spinning and going down the plug hole is that in that basin of water, there's just one funnel. It's a funnel, right? And it comes in from the top and it goes down, and then it falls down the pipe and you forget about it. And if you look at a tornado, it comes in the top and then it dissipates at the bottom. So we think of these vortexes, and they just come in the top and they go down and they stop. But the thing about an electric field, if you think about a magnet, if you've got a bar magnet, so it's, it's like this, and it's got a positive end up here and a negative end here, or other way, it doesn't matter. If you look at the lines of the magnetic force that go around that bar magnet, they look like this. There's a funnel at the top, and there's a funnel at the bottom. And when you think about spinning water going down a plug hole, you've only got half the picture. So there's actually two funnels. There's one going out the top, and bear in mind the top is random. I mean, as soon as you get off the earth and away from the gravitational field, there is no top. There's just relative to you. So we just use top and bottom because you've got to have something to say this end and that end. It could just as easily be north and south or positive and negative. That's actually, But if you have the funnel here, because of the charge radius of that charged particle, the things come in the top and they go down the middle, because remember there's a void in the middle of a hurricane or a tornado or a galaxy or a proton. That's the shape. But then it doesn't stop. It keeps going because there's a charge radius, and those particles don't normally escape the spin of the torus. They just keep going round and round and round and round and round and round and round. It's a very stable shape. And there is evidence to suggest that it's very, very stable. It's like, because it's actually pretty hard for the little particles or for anything to escape that toroidal thing. It just keeps going. And at the level of our protons and, the Planck spherical units and everything else, it just keeps going. It's like perpetual motion. There's this endless movement, endless spin, endless energy. And that's what everything's made of. And so I had to make the connection between, we've got spinning water to explain, you've got the density, you've got the strong charge and electric field that's close to the nucleus of the atom, and as you go out it gets weaker. I needed to explain that. But then I needed to explain that it isn't just the top half, it's a whole thing. It's a sphere, and there's like a convection current that just goes round and round and round. And of course I can't do it because I don't know the path, but it doesn't actually go round and round like this either. It goes sort of round and round like this. It just keeps spinning and spinning around and around and around and around and around forever and ever. And that is actually a Planck spherical unit. Really small, but that's what it's doing. It's just spinning electrostatic energy. Vastly powerful in a very small space. And then you think, well, what the hell's that got to do with matter and, the fact that I need money or I'm sick or whatever? Well, remember your body is made of that. And the very things that you want to create to sell or where you need to go to do it, all of it's made of that. And I know it seems like a long stretch, but if it's all energy and it's all information and we're made of the same stuff, don't forget your body's made of the same stuff. Shouldn't there be a way that we can start to interact with it and do things with it? And by the way, I don't have a bottled answer for that. But I can tell you that I'm figuring stuff out. I'm learning. I'm having experiences that I never would have imagined even a month ago because I didn't know the stuff that I'm learning now and actually teaching you in order to be able to go into the creative and meditative space that I go into to try it out and see what I can do. And things are happening. Strange, unexpected things. So I kind of get experimental, anecdotal, not, so this is not like a double-blind, triple placebo study. It's none of it's that. This is my personal experience. But this information that I'm unpacking for you is turning into experiences that sooner or later I'm going to unpack for you too. And if you decide that you would like to support me on my Patreon, you will hear about those things sooner because every week I share an inside insight from one of those experiences that I've had recently, and some of them are pretty wild. Because wild stuff happens. Because, aren't I playing in a wild place? Working with the PSU, saying, forget matter, forget emotion, whatever. Where's the resonance that's holding all of this stuff in the shape that it's in, and can I change that? Because that's where everything comes from. So anyway, diversion. So this is the thing. I wanted to explain fundamentally that what we think of as solid isn't solid. It's just these tiny, tiny little things. And the piece that I haven't talked about, that I did write about this morning, which I talked about before, but just bringing things back together, because, I say I want to talk about a PSU. Oh, it's electrostatic. What the hell is that? And I talk about potential energy in a system and charged particles and electric fields. And now we have all those concepts. But then I had to bring that back to what is a PSU. Because it's like we're going off on a great detour, gathering the information that we need to do to understand that. And so before all of this, I was trying to explain, and for myself too, how do you even imagine the size of this thing because it's so small? And so I used a comparison that Nassim Haramein made. And what he said is, if you take that teeny tiny little spinning vortex of energy and you make it the size of a grain of sand, which by the way is blowing it up hugely. Let's say a PSU is the size of a grain of sand. Spinning vortex of energy, right? Not sand, but it's that size. If you want to know how big the proton is by comparison, that proton is a huge sphere that reaches from here to Alpha Centauri, and it's full of grain of sand size spinning PSUs. I mean, there is a number that says how much that is, how many PSUs there are inside that. He worked it out. It's enormous. The point is, there's an awful lot of PSUs, grain of sand sized things, that can fit into a sphere that is as big across as it is from here to Alpha Centauri. Bear in mind that's 41.2 trillion kilometres. It's a long way. So between a PSU and here to Alpha Centauri is the size of the PSU and the proton. And then I wanted to work out how big the atom was. And this is just a hydrogen atom, which is really small. And when I finally got the math right, after getting it wrong 2 times, the third time, I think I worked out correctly that the hydrogen atom, by comparison, is about 5.25 times the size of the Milky Way. And all of it is spinning energy. There's nothing solid there. Nothing at all that's actually solid. The reason why we think we have bodies and we live in a world that, and there's stuff that you can bang into and it hurts, and there's other stuff you can bang into and it's ecstatic and wonderful, experiences and everything else, is because these tiny pieces of spinning energy have developed a charge, positive or negative, and they've found something else that's negative or positive, and they're stuck together. They've been bonded together by that charge. That's it. That's what holds everything together. That's what I've been trying to explain to myself and to you. And the point being that energy always comes with information, and information always comes with energy. Like, I'm sitting here in this room and it doesn't look like I'm sitting in anything, and yet there are radio waves, and there's Wi-Fi, and there's cosmic information that's come from the far side of the galaxy, the universe, whatever. There's all kinds of waves, energy going through this space that I'm sitting in, and just because we don't see it doesn't mean it's not there. You just need the right tool to be able to measure it. So we have a radio that can pick up radio waves, and that's cool. And we can have telescopes and other things out in space that can pick up the space information, And we have a Wi-Fi modem that can pick up the Wi-Fi. Well, don't you think that we should have some kind of capacity to relate to these Planck spherical units so that we can do something with them, so we can get some information from them, so that maybe we can work together to change things? I have this feeling that we should be able to. And what I'm starting to understand as I practice, this is so obvious, because we are sitting in a sea of these Plancks. And I haven't written about this yet, so I'm going ahead, but I seem to do this when I talk about this. We're sitting in a sea of it because the point is that the only difference between what we can't see and touch and what we can see and touch is that this has gotten enough electrostatic charge to hold the Plancks together. This hasn't. That's it. There's no difference. It's all the same stuff. And you know how some of us read energy? We feel things, we have intuition, we get a vibe. Well, how else is that coming to us if it's not coming in the stuff that we can't see? The only difference between what I can't see and what I can see is that these little packets of energy have gotten some information from somewhere, and they've formed into matter because they've made bonds. And it's possible to change that. I truly believe it's possible to change that with our mind. Not by going, that never worked for me. But to understand it and be able to work with it. And I mean, I had an experience this morning, and I'm not going to talk about that. I think I'm going to talk about it in the Inside Insight this week, because it's tangible and sort of concrete enough, even though in some ways you might say it's really esoteric. But I can explain it in terms of what I've just talked about now. So I'm going to share that with my patrons this week. I've just decided. So everything that we see and everything that we don't see, smell, taste, touch, hear, experience, in this universe, it's about those spinning building blocks. And there's so much more to explain, but it'll blow your mind because it's blown mine. And I don't want to go so far down the rabbit hole that we stop being practical. It's like, I imagine this God of me online offering that I'm creating, that I'm writing, being in modules. And I'm pretty sure that what I'm writing now is not a first stage module. It's probably a second stage module. But it adds so much to the basic model of understanding that is essential. I can't leave this out because it's made such a difference to my ability to understand and interact with and even believe that I can change my world and my universe. I've been developing that belief for a long time. It's not just this information that's made it bigger, but yeah, it's really made it bigger. So I don't know how long it's going to take. I'm just going to keep writing, and sooner or later I will in myself discover something that looks like a how-to that I can then break it down again and teach it and say, this is how you do it. And I'm really curious about what that looks like. But right now, I'm just writing, and I'm having the time of my life in my meditations, because I am actually changing matter with my mind. But you got to know how. What I can say in closing is that you don't need, if you have the skills, and I absolutely credit Dr. Joe Dispenza for giving me those skills, because without him, none of this would make sense to me. If you have the skills and you understand just a little bit, if you learn what he teaches, and you start asking questions and you have it in your heart that you want answers, you will find them. The field will teach you. Because it teaches me, and I'm no different from you. I just really, really want to know. And I keep asking, so the answers keep coming. Little by little, I'm learning. I'm remembering. So, I'll be back next week with lots of love. I look forward to seeing you then. Bye-bye.